Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. Yesterday, we began solving the data sufficiency questions from the official guide. And yesterday, as I explained to you, that this book contains the official guide that I just showed you. This official guide, 13th edition, contains 230 problem-solving questions. It contains 174 data sufficiency questions. We have solved all of these problems already. If you're interested in watching the original solutions to these problems, you will find them from day number 1 to 250. Right now, we are just redoing them at a little bit of a faster pace. So let's get going. Problem number 254, problem number 6 is what we're going to do right now. Problem number 6 is what we're going to do right now. Problem 1 through 5 we did yesterday on day number 52. It says that we have an expressway which has 4 exits. J, K, L and M in that order. It is very important that they emphasize in that order. And the question simply is, how much is the distance from K to L? The question simply is, what's the distance from the exit K to exit L? And here are our exits, J, K, L and M. And what we're looking for is K to M. This is the distance we're looking for, K to M. Let's see what the first statement tells us. The first statement tells us, I shouldn't have drawn this thing so low. The first statement tells us that J to L is 21. J to L is 21 miles. J to L is 21 miles. This is what we're looking for. J to K to L is what we're looking for. The first statement tells us that J to L is 21 miles. Here's your J to L. J to L. Knowing that the distance from exit K, knowing that the distance from exit J to exit L is 21 miles, does that enable us to answer the question that is being asked, which is how much is the distance from K to L? Knowing the distance from J to L, knowing that the distance from J to L is 21 miles, does that enable us to be able to answer the question, which is what is the distance from K to L? The answer, of course, is not. How can we figure out the distance from K to L simply by knowing the distance from J to L is 21? Statement number 1 is not sufficient. A, D, B, C, E. A, D, B, C, E. Again, one more time, as I explained yesterday, if you do not know what I'm doing here, it is very important that you watch intro. Just type in data sufficiency intro along with my name, Keshwani, and watch that video. Since first statement is not sufficient, we know that the answer cannot be A or D. Answer would have to be either B, C, or E. Let's look at second statement. The second statement tells us that K to M is 26. K to M is 26. Where is K to M? K to M is right here. K to M. Let's erase this part. K to M is 26. Again, simply knowing the fact that K to M is 26 miles does not enable us to be able to answer the question, which is what's the distance from K to L? How can we figure out distance from K to L? By simply knowing that K to M is 26 miles. The second statement is also by itself not sufficient. Second statement is also by itself not sufficient, which means answer cannot be B. Answer would have to be either C or E. We're going to put the two statements together, and if it turns out that we are able to answer the question that is being asked by putting the information from the two statements together, then the answer would turn out to be C. The answer in that case would be C, otherwise it will be E. Let's put them together, shall we? Let's put both the statements together. I'm going to erase all of this thing, we need the room. Here's what's going on. Here are our 4 exits, J, K, L, and M. We are told, in the first statement, we are told the J to L is 21. We are told the J to L is 21. In the second statement, they're telling us that k to m is 26. The question is, what is this distance? Do you see a problem? Do you see what's going on here? Do you understand what is being asked here? What is it that they're asking here? What they're asking here is, in a very roundabout way, in a very convoluted way, what they're asking here is that how much is the overlap between this part? What is the overlap? This is the overlapping region from J to L and from K to M. How much is the overlap? Well, we cannot tell that we cannot answer that question. See, let me show you in a little bit of a different way here. Think of this as J to L, and the other one is K to M, J to L, and K to M. K is somewhere on this thing, somewhere. We do not know where K falls towards the very end here, or whether K falls somewhere in the middle, or if K falls over here. And the other part here, this is the K to M. Where do they fall? Do they overlap like this a lot? Do they overlap a lot, or do they overlap just a little bit? I'm going to show you the two scenarios here. I'm going to show you the two extreme scenarios here. Here's scenario number one. If we put them together, maybe what we're looking at is this part. Here's our J, here's our K, and J to K is 1 mile, and here's our L, and this would be 20 miles. So J to K is 21 miles, and K to M we were told is 26 miles. K to M we were told is 26 miles, and this is 20, then this is 6 miles. So this is one possibility. In this case, the answer would be 20. K to L is 20. It's not drawn to scale. M will not be way over there, but you get the idea. You get the idea. It's not important. There you go. Another possibility is that instead of sharing such a large distance of 20 miles of overlap, maybe the overlap is only 1 mile. Maybe the overlap is only 1 mile. So here's our J. Here's our K. So instead of J to K being 1 mile and K to L being 20 miles, now we look at the reverse situation. Maybe J to K is 20 miles, in which case K to L is going to be only 1 mile, and J to L is 21 miles, and K to M we are told is 26 miles, and this is 1, this has to be 25. Now in this case, K to L is only 1 mile. So here's one extreme where the overlap is 20 miles, here another extreme where the overlap is 1 mile. The point we are trying to make here is that in a very, very long-winded way, what I'm trying to tell you is that the answer is E. There isn't enough information. It depends on how much the overlap is, and that is actually exactly what the question is. The question is how much the overlap. We can't really tell how much. Simply knowing that one distance is 20 miles and the other one is 26 miles, we can't really tell how much is the overlap. It all depends on how they're sitting, and which is what they're looking for. Let's go to the next one, number 7. Number 7, just give me 1 second. Number 7. Oh, I should have erased that part. Just type in data sufficiency and then intro. In number 7, we are told that n is an integer. N is an integer. And the question is n plus 1 odd? Which is another way of asking, is n even? Because if n is even plus 1, 2 plus 1 is going to be odd. So if the question is n plus 1 odd, which is same as saying, is n even? Let's see what we can do. The first statement tells us that n plus 2 is even. Well, if n plus 2 is even, this implies if n plus 2 is even, then n must be even. Then that implies that n must be even. And if n is even, then that implies that n plus 1 is odd. The first statement by itself is sufficient for us to be able to answer the question. Now the point here is not, listen very carefully, the point here is not that the answer turned out to be yes, it is odd. The question was, is it odd? And the answer here is, yes, it is odd. Yes, it is odd. and by it we mean n plus 1. But the point here is not that it turns out to be, the point here is not that the answer turned out to be yes. Even if the answer had turned out to be no, a definitive no, the first statement still would have been sufficient. The answer does not need to be yes. We don't care whether the answer is yes or no. We just have to be able to give a definitive answer, either yes or a no. Okay? Let's do the second statement. So the first statement is enough. First statement by itself is enough. AD, BCE. AD, BCE. Now, because the first statement is enough, we know that the answer cannot be B, C, or E. It would have to be either A or D. In the second statement, they tell us that n minus 1 is odd. Well, if n minus 1 is odd, that implies that n must be even. N must be even. If 3 minus 1 is odd, then n must be 4. N must be even. And if n is even, it will be the same thing. If n is even, then n plus 1 is odd. Second statement is also sufficient by itself. The answer is D. The answer is D. This was a quite straightforward, simple question. Let's move on. Number 8. Question number 8. Again, give me 1 second. Number 8. Number 8, we are being asked for which investment is the rate of return greater, J or K. We are being asked for which investment is the rate of return greater, J or K. Well, let's find out, shall we? Let's find out what they tell us in the two statements. First statement tells us that J returns $115 per 1,000. They also tell us that K returns $300 per 2,500. Well, we have clear-cut numbers here. We have numbers here that if we're getting $115 per $1,000, obviously we can figure out the rate of return. Here again we're getting $300 per $2,500. Obviously we can figure out the returns because we have solid numbers. We don't actually have to figure out the returns. Nobody's asking us what are the actual returns. We don't actually have to waste our time to calculate the returns and then say which one is bigger. That's not the point here. The point here, these questions are called data sufficiency. We just have to be able to answer the question, do we have sufficient data? To which the answer is yes. We do have sufficient data from statement 1. Statement 1 is sufficient. Statement 1 is sufficient. A, D, B, C, E. Because statement 1 is sufficient, we know answer cannot be B, C, or E. It would have to be either A or D. Now, what I'm about to do is not going to be damn silly in the real exam to actually do what I'm about to do. It'll be a sheer waste of time. We can actually figure out the rate of return just to satisfy our curiosity. It's very simple. J is $115 per 1,000 and K is $300 per 2,500. What we're going to do is make this is out of 1,000, this is per 2,500, this is per 1,000. Make them comparable by making these numbers the same. Let's do it then. Let's multiply both sides by 10 here. So here we end up with 1150 per 10,000, which of course we didn't have to do it here because it's 115 per 1,000 is 11.5%. It's 11.5%. We didn't actually have to do it here. We did it so that we can figure out this one very quickly. Let's multiply it by 4. Multiply this side by 4, this side by 4. So now we get 4 times 300, which is 1,200 per 10,000. And this one was 1150 per 10,000. And the question is, which one is greater? Of course, we can figure out the answer. This one is greater. It's 12%. This is 11.5%. But as I said before, this was a sheer waste of time. This is not something we'll be damn silly to do it in a real exam. Do you understand? Let's go to second statement, shall we? Second statement. The answer has to be either A or D. In the second statement they tell us, that K returns 12%. Well, simply knowing that K, the rate of return on K is 12% does not enable us to be able to answer the question, which is return on which investment is greater. We do not know. We do not know the return on K. The second statement tells us nothing at all about the return on J rather. It tells us nothing at all about the return on J, so simply knowing what the return on K is does not enable us to compare to be able to tell which one has a greater return. Second statement is not enough. Therefore the answer is A. Before we wrap up and before we go to the next problem, I just want to point out one thing here. Notice we just calculated the two returns and we found out the return on J was 11.5%. We found out the return on K was 12%, which is exactly what they tell us in the second statement. What I'm trying to make you understand is that they never contradict the two statements, that the information that they give you in the two statements never contradict each other. Do you understand? If you do your calculation and you find out that the Michael is 85-year-old in the first statement, and then you do the calculation based on what they tell you in the second statement, and you find out that the Michael is 8.5-year-old from the second statement, something has gone wrong. If Michael was 85-year-old from the first statement, based on the information from the first statement, then he better be 85-year-old based on the work that you do from the second statement. And if they give you contradictory information, that means you've done some mistakes, something has gone wrong. You're going to have to go back and check both of them because you don't know where you made a mistake. But they never contradict each other. Do you understand? If the first statement tells you that the sky is going to fall on Tuesday, and the second statement tells you that it's going to fall on Wednesday, well, something has gone wrong. Do you understand? Let's move on. Number 9. Question number 9. Question number 9. It says that a citrus fruit grower is growing something and is getting $15 for each tangerine. And he gets $18 for each grapefruit. I think in the problem they talk about different fruits. Oranges, they say. I don't want to use oranges because oranges, I don't want to use letter O for oranges, it will be confusing. So we're going to grow not oranges but tangerine. They're yummier, do you understand? Tangerines and grapefruit. And we're getting $15 for tangerine. We're getting $18 for each of the grapefruit. The question is, how many tangerines were sold last week? That is the question that is being asked. How many were sold? Let's see what they tell us, okay? The first statement tells us that last week, T was 20 more than twice G. The first statement tells us that last week we sold, number of tangerines sold were 20 more than twice the number of grapes sold. Let's see how the book says it. Last week the number of oranges that were the growers shipped, the tangerines, was 20 more than twice the number of grapefruit. How do we get an equation out of it? Well, it's very simple. Tangerine, T, was means equals 20 more than twice the grape. So here's the twice the grape. This equation tells us that number of tangerines sold was twice the grape. Number of tangerine that was sold was not twice the number of grapes sold, but rather it was 20 more than that. Here's our equation. The question is this enough? Okay, I'm slowing down here. I shouldn't. I was taking it a little bit too easy here. Question is, we have to keep a steady pace here. The question is this enough? The answer of course is no, it is not enough, because we have two variables, T and G, and only one equation. How the bloody hell do you expect me to solve for two variables from one equation? First statement by itself is not sufficient. First statement by itself is not sufficient. A, D, B, C, E. A, D, B, C, E. Since the first statement by itself is not sufficient, the answer cannot be A or D. Now we're going to look at the second equation. Now my gut feeling tells me that perhaps they will tell us something useful in the second statement which will enable us to extract another equation from the second equation, and then we'll have the two equations that we need to solve for the two unknowns. Let's see what they tell us. In the second equation they tell us that the revenue last week total revenue was 38,700. 38,700. This is where you're going to get a lot of people who are not very good in algebra are going to sit there and say, what the hell am I supposed to do with it, knowing that the guy had a revenue of 38,700. How does that give me any equation? How do I, if I get my second equation? Well, then you are at loss. In reality, this knowing that total revenue is 38,700 is in fact an equation that we're looking for, second equation that we were looking for. How do we figure out the revenue? How do we figure out revenue? If I'm selling apples and bananas, if I sell 2 apples and 3 bananas, and if I get $5 for an apple, and if I get $7 for a banana, well, there is my revenue. This is my total revenue. My total revenue is the number of apples that I sell times the price of the apple. I sold 2 apples, and the price of each apple, A represents in this equation, let me start again. In this equation, 2 will represent the price of apple. Listen carefully. 2 is the price of apple. I sold 5 apples. A represents the number of apples I sold. I sold 5 apples, and I was selling them for $2 each. So 2 times the number of apples will give me the revenue that I get from apples. And here I'm selling bananas for $3 each. Bananas I'm selling for $3 each, and B represents the number of bananas. Last week I sold 7 bananas. If I sold 7 bananas at $3 each, then the price of bananas times the number of bananas gives me the revenue that I generated from bananas. And this is my equation for the total revenue, which is exactly what we're going to do here. This equation tells us that the total revenue is, we're getting $15 for tangerine. So 15 times the number of tangerine that we sold, T represents the number of tangerine that we sold, and $18 which we're getting for grapes, and G represents the grapes that we sold. And that has to equal 38,700. And this is our second equation. But this equation by itself is not going to do any good, because we are looking at only the second statement by itself. Second statement by itself again is not sufficient, because we have one equation and 2 unknowns, tangerines, number of tangerines, and number of grapes. We cannot solve for T and G from the second equation by itself. Second equation by itself is no good, but if we put them together, we have 2 equations and 2 unknowns. We should have no problem solving for number of tangerines and number of grapes. The 2 equations together are enough. The answer is C. The 2 equations together are enough. Now, one last comment before I wrap up the whole thing. If you are a pure mathematicians, people who are very nitty-gritty about math, your math teacher, your algebra teacher will tell you that what I actually said is technically not sufficient, it's not correct. I'm going to say it one more time. The claim that we made is that since we have 2 equations and 2 unknowns, we should be able to solve for T and G. Technically, strictly speaking, what we should have said is that since we have 2 independent equations, these 2 are completely independent equations, we should be able to solve for T and G. In other words, if I give you one equation where A plus B is 3, and in the second equation I tell you that 10 times A plus 10 times B is equal to 30, well, here we have 2 equations, but we cannot solve for A and B here because these two equations are not independent. Second equation is just 10 times the first equation. These 2 equations are not independent equations. Here they are independent equations. Therefore, putting them together, we should have no problem solving for T and G. The answer is C. As far as the exam is concerned, we are done. We are done as far as the exam is concerned. Again, what I'm going to do right now, okay, it comes with a warning. This is not something we'll be damn silly to do in a real exam. We're going to actually solve for T and G purely for practice, just to get used to it. It doesn't hurt to get some practice in algebra because we do have to do these kind of problems in the multiple choice questions. So let's do them together, shall we? Let's start. I'm not going to take too much time, and I'm not going to explain too much. If you get lost somewhere, if you need more explanation, you can watch the original videos, day number 1 through 250. Look for the page number, look for the problem number, you will find it. Okay. there is our second equation here. Our second equation was 15t plus 18g equals 38. I see 15, I see 18, and I see 8 plus 7 is 15, 8 plus 7 is 15, and this is 3. That tells us that this number is divisible by 3. And if you're lost already, then you watch the original solution. Do you understand? This number is divisible by 3, this number is let's divide the entire equation by 3 so that we can get a simpler equation. If you divide 15 by 3, we get 5. This is going to be 6g. 3 divided by 3 is 1. How many 3's does 8 have? 8 has 2 3's. The remaining 2 goes and joins the 7, becomes 27. How many 3's in a 27? 27 has 9 3's. So we get 12,900. That's our second equation. Our first equation was, first equation is right here still. This is our first equation right here. So what we're going to do is, we're going to substitute this first equation, t equals 2g plus 20. T equals 2g plus 20, I'm going to put it in here. T equals 2g plus 20, we're going to replace this t with 2g plus 20. 5 times 2g plus 20 right here plus 6g equals 12,900. As you can clearly see now, we have one simple variable, one very simple linear equation. We just have to solve for g. Once we know the g, we can figure out the t. Let's do it. Just very quickly finish it up since we started it. This is going to give us 10g plus 5 times 20 is 100 plus 6g equals 12,900. 10g plus 6g is 16g, 12,000, and subtract this 100 from here, so this becomes 800. Oh, there you go. I see 16 here, which is divisible by 4. I see 12 here, which is divisible by 4. I see 8 here, that's divisible by 4. Let's divide both sides by 4. So this becomes 4, 12 is going to become 3, 8 is going to become 2, and then we have a 0 and 0. Oh, then I see 3200. So again, we get 4g equals 3200. Let's divide both sides by 4. Oh, there you go. G equals 800. G equals 800. That wasn't bad at all. G equals 800. T, we know, T we were told is 20 more than twice the number. 20 more than twice the number. Twice 800 is 1600 and 20 more. So it's 1600 plus 20. Very good, there's your T. That's it. But we didn't have to do this for the real exam. Do you understand? I'll see you tomorrow, okay? Bye now.